So hi everyone, welcome back. So for this video, we're just going to continue about our topic for definite integral. But for this video, we're already going to start on discussing about plane areas. When we say plane areas, we are going to deal with two-dimensional figures. So we have the y-axis and we have the x-axis. Okay, so plane areas, if a continuous non-negative function f of x defined over an interval ab, then the area enclosed by a curve y is equivalent to f of x. So this is your function f of x and your interval is from point A to point B. Then the area enclosed by the curve and the vertical lines A and B and the x-axis is defined to be the area is equivalent to the integral of f of x dx from point A to point B. Okay? So, for the computation of plane areas are rectangular coordinates. In plane area problems, we divide the area into a rectangular axis and with thickness d of x or d of y, as the case may be. The area to be found is clearly the limit of the sum of the areas of these elementary rectangles as their number increases without limit. So we express the area of an elementary rectangle in terms of x dx and or y and dy to obtain the change in the area. So the limits of integration are determined from the figure of integration. dA is carried out between these limits. So ano ba yung sinasabi sa ating definition? So for example, you have here your curve y is equivalent to f of x. Okay? So we are going to consider a strip. So imagine this ruler as the strip na gagamitin natin. So it has a width of dx. So it has a width of dx and it has a height of dx. So imagine this is an infinitesimal value. So sobrang liit niyan na kung saan we have here your curve, kahit na ipatong natin paunti-unti yung strip natin until such a time that we can cover all of the area of this curve. So, ang parang magiging itsura niyan would be like this. So, if this is your curve, for example, this is your curve, you have here, yes, that is your curve. I am going to use a strip, oriented vertical strip. Gagamit ako ng maliliit na vertical strip. And that's it. That will cover the entire area of the curve that I am trying to get. So the height here would be f of x and the coordinates here would be x1, x2, x3, x4 until x of n. Okay, so the coordinate here at the top would be x1, f of x1. Therefore, to get the area, it is simply f of x times x of k. So from coordinate 2 to coordinate 1, so that is x2 minus x1, that is equivalent to delta k, delta x. So if I am to use this, I am to substitute this here, that would be f of x delta x. So to solve for the area of this curve bounded at the y-axis and the x-axis, it is simply the summation of f of x delta x up to a point k. Okay, so wherein if we are to define that, d of x is this one. It is the differential of the x-axis, d of y. If I am going to use a horizontal strip, that would be the differential of y. Then dA is the differential of area of the rectangle. So like what I've said kanina, what I am considering is a small strip of rectangle that will be covering the entire curve. So maliliit yan. So ipag-add ko sila, then I can get the area that I need or that I want. So that is equivalent to y dx. So that is y times dx. Okay, y dx from x to 1. So that for the summation, it would be from x to 1, our upper limit and our lower limit. So that is the integral of dA is equivalent to the integral of y dx from x1 to x2. Therefore, area is equivalent to the integral of y dx from x1 to x2. Okay, kung babasahin natin yan, this would be y times dx, and ang limit is, or it will be moving from point 1 to point 2. So that would be the interpretation. Now for the horizontal element of area, this time I am using a horizontal strip. It is the same principle, no? I'll be using small strips of rectangle that will cover the entire area of the curve plus the bounded by the y and the x-axis. So that would be x dy. So the differential of dA is equivalent to x. So this is x times dy from y1 to y2. Okay, so with that, I think we're already ready to proceed with our example. Before we proceed with our example, let us first try to define or try to understand our signs and limits with respect to the quadrant. Okay, so integral with negative integrand. So indefinite integral f of x dx from a to b, let the limits be chosen so that the lower limit is algebraically less than the upper limit. So dapat yung lower limit natin, it should be less than b algebraically. So when we say algebraically, so for example, this is negative 1, then the upper limit should be greater than negative 1. With this connection, x increases so that dx is positive. So we are using the integral to compute an area in the ordinary sense of elementary geometry. The formula must always be written that the element is positive since area is positive. Because it doesn't make sense if we are going to compute an area which is negative, because an area will always be a positive. Okay, so here we define dy is the differential of y, dx is the differential of x, and dA is the differential of a, and that is the area. And what area am I considering? It is the area of the strip, or it is the area of the rectangle. It's either oriented vertically or it is either oriented horizontally. Okay, so for horizontal element of the area, this is for quadrant number 2 and number 3, it is x, so that is x dy, and our limit would be from y1 to y2. Same with quadrant number 3. If I am using a horizontal strip, this one, horizontal strip, this is x times dy. And my limit would be from y1 to y2. Okay? And for vertical element of an area, this is for quadrant number 2. This is quadrant number 2. It would be y, the height of the rectangle, times the width, which is dy, from x1 to x2. And for y, for the third and for the fourth quadrant, it would be negative y times dx, and our limit would be from negative 1, from 1 to 2. But take note, for quadrant 3 and quadrant 4, it is negative sign. That is to make it positive, for the area to be positive. So for for the horizontal element 2 and 3, it is also negative. So to make our area positive, because our area is positive. Okay? So in computation of plane areas, normally when we are dealing with curves, we encounter it to be a parabola. So let's have a short recap of parabola. So if you have here y, quantity y minus k, quantity squared, is equivalent to 4a times x minus b, then this is a parabola, and that parabola is opening to the right. So if you have here your equation, y minus k, quantity squared, is equivalent to negative 4a times quantity x minus 4, then it is concave to the left. Okay? If you have your parabolic equation like this, quantity x minus h squared is equivalent to 4a minus k. 4a times quantity y minus k, then it is concave upwards. And if it so happen that it is x minus h quantity squared is equivalent to negative 4 times a times quantity y minus k, it is concave downwards. Where the vertex is located at hk. Okay? So we have here example number 1. Find the area bounded by the curve x squared is equivalent to 5y and y is equivalent to 1. So we need to make sure that this equation should look like any of these 4. Okay? Because we're quite sure that this curve is a parabola. So we have here, so we rearrange our equation for the curve. We have x squared is equivalent to negative y minus, or yeah, so that is minus 5. Okay, so if we are to base it here, it is this one. So it is concave downwards. Next, we have to determine the vertex. And the vertex is from this. Vertex is hk. What is h? It is 0. And k is 9. Okay? So, at y is equivalent to 1, we substitute the value of y to our main equation. And that would be x squared is equivalent to negative 1 minus 5. So 1 minus 5 is negative 4 times negative x squared is equivalent to plus minus 4. Therefore, x is equivalent, negative 4, positive 4. No, that is positive 4. Then this the root of x squared is equivalent to plus minus 2. And that is the x coordinate. Okay, so we're now ready to plot our curve. So we have here the y coordinate and we have the x coordinate. Okay, so it is opening downwards. So the vertex is at 0. Ibig sabihin nun, dito natin siya makikita. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is in 0. We all know that a parabola is symmetrical. Okay, so if I am to draw my parabola and it is pointing downward, it should look like this. Okay, so it should look like this because it is concave downward and y is equivalent to 1. So this is 1. So this is the line. So this is my x squared minus is equivalent to 5 minus y. And this is my line which is equivalent to 1. Okay?